All right, so today we're going to do more sum and difference problems, but we're going to do these with our special right triangles, the 30, 60, 90, 45, 45, 90. So we're going to be using the back of the formula chart and our knowledge of the special right triangles to come up with general solutions. So let's recall general solutions really quickly. We've got some just very quick problems here to do just to recall what they were. So if I told you sine of x equals half, well, the first thing you would do is say, well, x equals sine inverse of half. We're trying to solve for x, so you need to isolate the variable. So x equals sine inverse of half. And if I draw that triangle, the obvious triangle for us all to draw is in quadrant 1, where the opposite is 1 and the hypotenuse is 2. We know this would be root 3, and this would be pi over 6. So x equals pi over 6 would be a general, or it would be our principal value. That's our first answer. But remember that we also had a second answer, and that second answer, you had to determine where that quadrant would be so that it maintained the ratio 1 over 2. And so we could draw a second triangle, but it would be in quadrant 2, because in quadrant 2 I can still go up 1 and over and a hypotenuse of 2. So this would now be a negative root 3, but that doesn't really matter that much because I maintain the ratio up 1, hypotenuse 2. The 1/2 that I was given here is what I'm trying to maintain. All right, so this is still a 30-degree reference angle, but that's not our answer. Our answer is the angle that gets us there. So all the way over here is 5 pi over 6. All right, now these two things together make your solutions in one triangle, but we could also say if I go in a full circle around, I would hit that same answer. So we also added and subtracted 2 pi n. So added and subtracted 2 pi n. So these are our general solutions. X equals pi over 6 plus or minus 2 pi n and 5 pi over 6 plus or minus 2 pi n. So that's our general solutions for that first example. All right, so let's do cosine x equals negative root 3 over 2. So make sure you got this copied down. I'm about to erase all this so that we can do the next example. All right, so cosine x equals negative root 3 over 2. So the first thing you want to do is isolate the variable. So I can isolate the variable by saying, well, that's the same thing as x equals cosine inverse of negative root 3 over 2. And so the very first quadrant I would draw would be actually in quadrant 2 this time, because if I want my adjacent to be negative, that's got to be in quadrant 2. So you can go ahead and start thinking, where else would you be drawing that if you want your adjacent to be negative? But right now we're doing this one. So we actually just did this angle a second ago. This is the angle 5 pi over 6. So that would be one of our solutions. Let's go ahead and try to find where else you could have an adjacent that's negative. And so that would also happen in quadrant 3 here. So I'll draw quadrant 3. So in quadrant 3, I could still have a negative root 3 with a hypotenuse of 2. Now my opposite would now be negative 1, but that doesn't matter. This is still pi over 6, but now I'm going to 7 pi over 6. So there are my two solutions, and we will write that in the final answer to have I'll write it up here. X equals 5 pi over 6 plus or minus 2 pi n. and 7 pi over 6, plus or minus 2 pi n. So those are the answers for that question. All right, the last example we've got is tan x equals -1. So while I'm erasing this, why don't y'all go ahead and isolate the variable. So when you isolate the variable, you should get x equals tan inverse of -1. Now, tangent was negative in quadrant 4. This is, I'm kind of thinking about cosine secant lie on a cot, so that's why I know it's in quadrant 4. And your opposite is -1, and your adjacent is 1. So that's a 1, 1, root 2 triangle, which is 45. So the angle there is negative pi over 4. Now, if anybody was thinking about drawing that in quadrant 2, that's actually a fine answer because when we're talking about general solutions, it doesn't really matter as much, but I still have the habit of going through the rules of cosine secant lie on a cot. I'm going to go ahead and write out my answer because if you remember, tangent was special in 2 ways. You only have one general solution. In addition, you only add pi to that answer instead of 2 pi n. So this is that general solution for tangent. Okay? Now, what I was saying a second ago, if you had drawn this in quadrant 2, you would have still gotten -1. I'm sorry, that would have been +1. -1 here, root 2. So your opposite 1 over -1 still would have been -1. So we still got the answer. Our angle would have changed. This would have been the angle 3 pi over 4. But what I want you to notice is that these are actually the same answer, because if you take -pi over 4 and add pi, you actually get to 3 pi over 4, right? Because, let me show you that. X equals -pi over 4 plus pi. Well, get a common denominator. That's 4 pi over 4, which gets you to that 3 pi over 4. So really, it doesn't matter which answer you do. That's the reason why we only have the one answer, is because it's going to accommodate for both. So my point is I don't really have to see quadrant 4 here. If you would have drawn me quadrant 2 and gotten 3 pi over 4, I would have accepted that as a perfectly fine answer. All right, let's go ahead and keep going. So this is all old stuff, hopefully. Hopefully this is kind of just a quick reminder as to what general solutions are. Also do a quick recall. If you saw root 2 over 2, we got in the habit of changing that to 1 over root 2. This was root 3 over 3. We changed to 1 over root 3. And finally 2 root 3 over 3 was 2 over root 3. These are like the rationalized version of this. So there we go. All right. Now, what we're doing, though, is we are trying to do general solutions with our sum and difference rules. So, here are the steps right here. You're going to try and match your equation to a sum and difference formula. Take the inverse of both sides, solve to find the general solution. So we do want to find general solutions, and then after we find the general solutions, we'll find some particular values from 0 to 2 pi or 0 to 360, depending on radians or degrees. So I'll explain what part B means after we find the general solution. All right. So in example 1, we have sine theta cosine 40 minus cosine theta sine 40. And really, this should probably say degrees. It's kind of tacky just because I know that that is supposed to be a degree. So that should really say degree. And I know it's degree because I see the theta, so it's definitely in degrees. And that equals root 2 over 2. Well, the very first thing I'm going to do is I'm going to cross that off and just write 1 over root 2. Because we can't really solve it. This is clearly a 45-degree triangle. But what are we going to do with all of this? Because all of this is not something that you can take apart individually. And we don't know what cosine of 40 degrees is because I don't have a 40-degree triangle I know how to draw. So what I'm going to have to do is try to match this up using your sum and difference rules. So if you look on your formula chart, you're looking for sine cosine minus cosine sine. So that actually matches exactly. I'm going to write out the whole thing just because I can't show you the formula chart, but I won't do this every single time. So I have, one of my rules is sine A minus B equals sine A cosine B minus cosine A sine B. So the reason why I know that this matches is because, let me bring this back now, because I've got sine of something first, then cosine of something different, minus symbol, cosine of, and this very first, this letter A should match this letter A. So this theta matches this theta. And then lastly, sine 40, sine B, again noting that the B, the 40, matches. So I could say all of this is sine of A minus B, where A is the theta and B is the 40. So all of this is going to become sine theta minus 40. And I'm going to put degrees there. Okay, so I'm just rewriting that left-hand side as sine theta minus 40. I'm going to set that equal to 1 over root 2. All right, so the next thing I would want to do is I will go ahead. I'm trying to get theta by itself, right? That's the goal, is to get theta by itself. Well, I have to get rid of sine, so I'll sine inverse both sides. So now I have theta minus 40 equals sine inverse 1 over root 2. And then the last step is to go ahead and add 40 to both sides, but you could do that if you wanted to, but it's probably easier if we go ahead and solve the answers here, get our answers from here, and then add 40 afterward. If you just wanted the equation, sure, you could add 40. But since I'm actually looking for the answers here, I am going to go ahead and get these answers. I should have done that in a different color. I'm going to go ahead and get these answers. And after I get these answers, then I will add 40. So this is kind of going back to what we did at the top. Well, sine inverse of 1 over root 2. It's positive, so I'll start in quadrant 1. And I do know that that's a 45, we're in degrees, 45-degree triangle. And in quadrant 1, 45 is going to stay 45. All right, and then in quadrant, where the second one is going to belong in quadrant positive 1. Opposite needs to stay positive. Where does that happen? So that does happen in quadrant 2, 1 root 2. This is still 45 degrees, but remember now your answer would be 135 degrees. All right. Now, I kind of warned you about this. This is the answers, though, to this side of my equation. Well, now with this as my answers, I'm going to go ahead and add 40 to these answers. And I do need to add it to both answers because this is like an equation that gets me two answers. And so theta can be this answer plus 40, and theta can be this answer plus 40. So I'm going to show this step in red. I'm going to add 40, and I'm going to add 40 here as well. So my first theta answer I'm sorry. All right, so my first theta answer is that theta is going to equal, so this makes 85. And then we're still going to add a full circle around, any full circle plus that, all right? And then my second answer is 135 plus 40 makes 175 plus 360. So this is my general solutions. Theta equals 85 plus 360n and 175 plus 360n. All right, now the second part of the question asks us to get particular values, so I'm reading part B from, from 0 to 2 pi or 0 to 360. So we're going to be concerned with 0 to 360 because we are in degrees. And so if I take a look at what that means, well, I know that my first answer, we do want to go in smallest to largest order. So my first answer is 85, and that's a number between 0 and 360, so that works. Now, my second answer is going to be 175, and that's again between 0 and 360, so that works. Now remember, the whole point of this is to say, well, not only is 85 an answer, but so is 85 plus 360. But part B only wanted me to go from 0 degrees to 360. So if I add 360 to 85 degrees, I'd obviously be above 360. So these are the only two answers I'm going to write down for part B. We used to write down 1, 2, and 3. It's just changing the instructions a little bit to just kind of give you more than one type of question that I could ask you. So for instance, if this was to 720, we would probably get one more from each, and that would get us all the way up to 4 answers that would be between 0 and 720. Okay, it's not always going to only be 2 answers though. So I mean, don't just get used to only 2. It's going to be keep giving me answers until you pass 360. All right, let's go on to the next slide. All right, so in example 2, I have cosine x times cosine pi over 4 minus sine x sine pi over 4 equals 1/2. I am in radians this time, something to note. And when I try to match this up, what are you going to match this left-hand side to? So you're looking for cosine, cosine, minus sine, sine. So it matches up exactly to, and I'm just going to write the side we're going to be concerned with, cosine A plus B. So if you didn't find that, go ahead and look at it now, see why it matches up. And I know that my x is my A because that's the first thing here, and my B is pi over 4. So this is going to be cosine x plus pi over 4 equals 1/2. Okay, all right, so my next step is to go ahead and get rid of this cosine by taking its inverse. So now I'm left with x plus pi over 4 equals inverse cosine of 1/2. All right, so I'm looking for ratio of cosine 1 over 2. I am going to have 2 answers. So my first one's in quadrant 1, and this is 1, 2. That would make this root 3, so this is pi over 3 as a first answer. Now where's your second answer going to be? How can you maintain a positive adjacent? So you can maintain a positive adjacent with quadrant 4. So this is 1, and 2. This is root 3. It is negative root 3, but that's fine. And this is negative pi over 3 now. All right, but that's not all we have to do, because now this is an answer to just the right-hand side. And so in order to get x totally by itself, I'm going to have to subtract pi over 4. So pi over 3 minus pi over 4 is an answer. And then over here, negative pi over 3 minus pi over 4 is my other answer. Well, I do definitely want to get my physical final answers here. So I need to get a common denominator. This is kind of annoying, but it's just getting a common denominator. So that's 4 pi over 12 minus 3 pi over 12. So that is pi over 12. Okay, and then over here, so that's negative 4 pi over 3 minus 3, not 3, I'm sorry. The whole point of that was to make the denominator 12, of course. Minus 3 pi over 12 makes negative 7 pi over 12. All right, so I have this and I have this. Those are my general solutions. Well, they're the part of the general solution. I need to still add 2 pi into that. So, all right, so let's go ahead and get answer A is the general solution. So x equals pi over 12 plus 2 pi n and negative 7 pi over 12 plus 2 pi n. And then part B asks for, so I'm just going to write it out so that I don't have to flip back, from 0 up to 2 pi. So how we used to do this is a fine method. Since one of these is positive and one of these is negative, I'm definitely going to start with the positive. Now if you take anything and add 2 pi to it, won't it be greater than 2 pi? So yes, it will. It'd be 2 pi plus pi over 12, which is greater than 2 pi. So this is my first one, and I don't need to find another one from this equation. But now if I go down to this equation, since it's negative, I can't really start with that. So in order to get my second one, I'm going to take negative 7 pi over 12, and I'm going to add 2 pi. Well, still common denominator, so that makes, so 12 makes 24 pi over 12. Negative 7 plus 24 is 17. Okay, and that's my answers to part B. Here's my answers to A, my answers to B. All right, so let's start our last example, example 3. So this is tangent 3x minus tangent x all over 1 plus tan 3x times x. So if you match this up, what does it match to? So I'll do the same thing. I'll just write the simplified version so that you can see what I've matched it up to. Alright, so it matches to tangent of A minus B. So A is the first thing, so that's 3x. Oops. And B is the second, which is x. So this matches up to tangent of 3x minus x. This is a little bit different than what we've done so far because you can keep going. I mean, the point of this was to simplify as far as you can simplify. Well, tangent of 3x minus x is tangent of 2x. So I'm going to change all of that. All of this is really just tangent of 2x equals, and I'm also going to unrationalize that, negative 1 over root 3. Now remember, tangent is special for two reasons. It's only got one triangle, and it's only going to be adding pi, so keep that in mind. So I'm going to inverse tangent. So now I have 2x equals inverse tangent negative 1 over root 3. Alright, so let's get the answer to this. And then after I get the answer, I'll divide by that 2 to get x totally by itself. So this would be drawn in quadrant 4. Remember, I'm not really that particular on this, but I'm going to follow the rules of cosine, secant, lie on a cot. Opposite is negative 1, root 3, 2. So that makes this negative pi over 6. Alright, well, what happens if you take negative pi over 6 and you divide by 2? Well, dividing by 2 is really the same thing as multiplying times half. And so that's negative pi over 12, which makes sense that if you have a sixth of a pie and you divide it into 2 slices, then each person would get a 1/12 of a pie, a smaller portion of the pie. All right, so that's it. Remember, we only have one triangle here, and I've already divided by that 2. So x equals negative pi over 12, and then also special because I'm only going to add pi in. Alright, I hate doing this, but I was wrong. So what I want us to do is go back to this step right here. Think about, before I tell you why I'm wrong, I want to explain. If I got that this was 2x equals, so my first answer, I'm going back up to this step way up here. Negative pi over 6 was an answer, and I'm only going to add pi to that. So before I divided by 2, this is what that would have looked like. Now, when you divide by 2, this is where I'm wrong at. When you divide sides by 2. This entire side divides by 2. So it's not only the negative pi over 6 that gets divided by 2, but also the pi that gets divided by 2. Now don't totally freak out because the rest of the notes that I've done are correct. And I'll go back and explain why those are correct right in a minute after I finish this problem. But this is just going to be negative pi over 12, and then I'm going to end up doing plus pi over 2n. This is what is majorly different because when you divide sides, so that divides also. All right, so that's our general solution. So part B. So I can't start with negative pi over 12, so I am going to add pi over 2 to that, and that's actually going to turn into 6 pi over 12. So that's going to be negative pi over 12 plus 6 pi over 12 makes 5 pi over 12. Now we want to keep adding until we get past 2 pi. Well, if I add another half of pi, or 6 pi over 12, I get to 11 pi over 12. Is this close to 2 pi? Well, is 11 over 12 close to 2? No, it's actually pretty close to 1, but not close to 2. So keep adding. 6 pi over 12 makes 17 pi over 12. What is 2, by the way? 2 is going to be 24 over 12. So 24 over 12 is where I have to stop. If you add 6 pi over 12, are you going to make it there yet? So 17 plus 6 is 23. So that's actually quite fine to do one last time. And I would get to 23 pi over 12. Okay, so this one has 1, 2, 3, 4 solutions that are greater than 0 but less than 2 pi, because 2 pi was 24 pi over 12. All right, now I told you I was going to go back and explain why everything else is okay that I did. I just forgot the whole dividing thing. So if you divide, because you have to divide the side by 2, we also need to divide that pi by 2, and that's how it became pi over 2. But it's okay that we didn't do that everywhere else, because remember, everywhere else was addition and subtraction. And when you add and subtract, they only add and subtract to their like term. So that answer, okay, so if I go back to example 2, I got an answer of pi over 3. Let's go ahead and do plus or minus 2 pi n. Now when you subtract the pi over 4, subtraction is only going to go with like terms. So it's not like I would have been affecting this anyways, because this is just a subtraction. So you would have matched it to its like term and only subtracted that. So my problem was that when you divide the entire side. But when you add or subtract, you're only going to do it to the like term. So keep that in mind when you're doing your homework tonight. Okay? And that's it for the lesson.